Alright, today we're doing solving combined inequalities. So, when you have combined, or we also call it compound, okay? Can be either one. Compound inequalities, combined inequalities. When it says or, so you have one inequality or another one, solve one, solve the other, graph on the same number line. Okay? For and, like this, if it's written like this one, solve one, solve the other, then graph on the same. You will see some and statements that may be written like this. You want to separate into two inequalities. Solve one, solve the other, and that's separately, and then graph on the same number line. Okay, so there are the two. So let's do a couple of these. This is, the first one is an and statement. So basically, solve this one over here. I minus the 2. I get c is less than or equal to 1. Over here, that's a positive 4, so I have to minus 4. Negative c is greater than negative 2. And then because that's a negative, I'm going to divide by a negative 1. Because I'm dividing by a negative, I flip that to be less than. Negative 2 divided by negative 1 is 2. So I have c is less than or equal to 1, and c is less than 2. So here's 1 less than or equal to, here's 2 less than, and is just shaded for both. So I just want this piece, so I'm going to go from here down. Okay, and my answer essentially is c is less than or equal to 1. But that's fine if you write that. Alright, the second one is an or statement. So we just solve 1. On this side I have to divide by negative 1. So I get n. I'm dividing by a negative, so it becomes greater than 2 divided by negative 1 is negative 2. Or solve this one. Add 3 to both sides. And divide by 2, so n is greater than 4. So I have greater than negative 2 or greater than 4. So here's negative 2. Greater than 4, which means I just have from here down. Which means I have both of them shaded, not just, but from negative 2 all the way down covers both of them, because that's an or statement. Okay. Next, all right, here's an or. So solve on this side, add 1. I get 2x is less than negative 1 plus 1 is 0. Divide by 2. 0 divided by 2 is 0. On this side, add 1. 2x is greater than 2. And divide by 2, x is greater than 1. So x is less than 0, or x is greater than 1. And this is or, so is that okay? Yeah, perfectly fine. You could be here or here. So that's it. Next one. This is an and statement. That's what I was talking about. So we split that up. 4 is less than 2x minus 2, and 2x minus 2 is less than 10. So you take 2x minus 2 is less than 10, and 2x minus 2, 4 is less than 2x minus 2. So that's how you split it up. The 2x minus 2 is on both. Okay, so here you solve, you add the 2, you got 6 is less than 2x, divide by 2, 3 is less than x, or flip that, x is greater than 3. I just flipped the entire thing so I know how to graph it. Okay, over on this one, we add 2, so you have 2x is less than 12, divide by 2, x is less than 6. This is and, so I have greater than 3 and less than 6 means I have just what's in the middle. Okay, now I'm going to show you another way to solve that. Perfectly fine to split it up, but also perfectly fine. What I've done this past is say, okay, and it's hard for me to show it here, but if you cover up the 4 is less than, Okay, cover that up until all you're reading is 2x minus 2 is less than 10. What's the first step you're going to do to solve that? Yeah, we add 2. So when you add 2 to all three things. Okay, 4 plus 2 is 6, negative 2 plus 2 cancel, and 10 plus 2 is 12. Again, cover up the 6 is less than. You just have 2x is less than 12. How would you solve that? Divide by 2. So divide by 2 everywhere. So I get 3 is less than, x is less than 6, which is that graph. Okay, so another way, if you don't want to split it up into 2, that is another way to solve it. Okay, you can do them either way, doesn't matter. Okay. Next, that's the same one. All right, number 5. We have 14 is less than or equal to 3h plus 2 is less than 2. So first thing, split it up. And 3h plus 2 is less than 2. So on the left, we minus the 2. I get 12 is less than or equal to 3h. Divide by 3. 4 is less than or equal to h. Or, so I know my graph, greater than h is greater than or equal to 4. On the other side, minus 2. Divide by 3. 0 divided by 3 is 0. So I have less than 0 and greater than or equal to 4. And because this is an and statement, what does that mean? Yeah, no solution. Okay, no solution. Draw it right over your graph. Okay, then we're clear. All right, this one right here, another one you can split up. 4 is less than or equal to x minus 5 over 2, and x minus 5 over 2 is less than 10. So to solve, we get rid of a denominator by multiplying. 2 times 4 is 8. 2's cancel. And then add the 5. So I get 13 is less than or equal to x, or how I like to write it, x is greater than or equal to 13. And on this side, multiply by 2. So you have x minus 5 is less than 20. Add the 5. You get x is less than 25. This is an and statement, so I have greater than or equal to 13, less than 25, and is just in the middle. So just that piece. Okay. And finally, number 7, so just solve them both separately, minus the 3. I have x is greater than negative 5. And on this side, minus the 1. And divide by 2, so x is less than 2. So less than 2, greater than negative 5. It's an or statement, which means everything would be covered, all real numbers. Okay, all real numbers. And that's it. Lots of examples there for you to take a look at. Here's some more for you to try. All right, but go through, take a look at all the various ones we did. Try the U-tries out, and I'll answer questions tomorrow. Thanks.